All right, happy, what's today? Wednesday the 9th. We are almost there. Test tomorrow, so online people, it'll be in there as an online option for you. It'll open up tomorrow, so you can do that. Make sure you submit online the worksheet 4 or 5 in the review. And then, especially you guys watching at home, I got to have everything in. You guys here as well, by the way. I got to have, if you want to turn it into something, I got to have it by the 11th. So that I can get everything, cleaned up, graded, inputted, all that stuff. Don't walk in the day of the final or email me something on the day of the final and, oh, will this bring my grade up? No, you got to have it in by tomorrow. So most of you in here and online there are doing just fine on that, but a few of you are missing some things. Get them done by tomorrow or don't get them done at all. Let's do some warm-ups, kind of day 2 of warm-ups. Hope you looked at day 1 of warm-ups yesterday. Test-inspired. Here's some more test-inspired warm-ups. These are we'll do in 2 sets again. So there's the first set. If you're at home, press pause and give those a go, and then unpause and we'll go over them. All right, looking at these, we have a 5 and a 7. Find A1 and R. Now, the way we've been doing it, we've switched the order of those. I would find R first. If you have a way to find A1 first, that's fine, but I think finding R first is the way to go, because if I start at 4, which is the 5th term, and I want to get to the 7th term, that's 2 steps away. So I need to multiply by R twice to land at 1. That's the first equation I would write. If I start at 4, I multiply by R 2 times to get to the 7th term. So R squared is 1/4, which means R is 1/2. To get to A1, I need to back up 4 times. So I need to start at, if I start at A1, or A5, and I back up, so I'm going to divide by 1/2 4 times, that will get me what A1 is. Now, if that's kind of complicated, another way to do that is to just sort of list out the terms, because it's not too hard to get to the 5th term and the 7th term. This also can check what we've done so far. If R is 1/2, then 2 and 1, and then so we see going backwards, we can just work our way backwards. So the first term is 64. So there's nothing wrong. It's not cheating if you lay out the terms and use that to help you, sort of navigate forward and navigate backwards to find the term you want. The formula. Let's see, we started the first term and multiply by 1/2 in -1 times. Again, you can look that formula up. I hope that we've done it enough that it becomes, you understand it, and so you could write the formula without looking for it. But if you need it, you got notes, then that's fine. A9 would be 64 times 1/2 to the 8th. 64 times 1/2 in parentheses to the 8th. Your calculator tells you that's 0.25. That's an exact answer, so that would be okay, but 1/4 might be a better answer. And some of you thought, well, I can, instead of a formula, I can just get there by extending what I know by 2 more terms. There's the 9th term, the 7th term, the 4th term, the 1st term. And so you can kind of do it all with formulas, but you can also do it with just sort of feeling your way around forward and backwards. And either one is fine, or kind of do both to check each other. All right, we're doing warm-ups in 3 sets today. So here's the second part, finding sums. And remember, there's 3 separate sum formulas, and there's 3 examples there. So my guess is you use each sum formula 1 time. If you're watching at home, press pause, give them a try, and then unpause, and we'll go over them. these. That first one, maybe you can look at it and tell what kind of sequence it is, but the safest thing to do would be write out a few terms and then convince yourself of what's going on. So if I plug in 1, I'd get -1. In fact, you could even write them up here if you need to. If I plug in 2, I would get 1. I plug in 3. 6 minus 3 is 3. And I think I see the pattern here. So it's arithmetic, which means n times a1 plus an all over 2 for the formula. So obviously you got to pick the right formula. N is how many terms there are. Well, from 1 to 50, that would be 50 terms. The first term we already got, that's -1. The 50th term I don't have, but I can figure that out. -1 plus 2 times 49, because we'd be 49 steps away from our first term. -1 plus 98 would be 97, all over 2. So 96 times 25 is 2400. I saw that on a number of papers, so I feel good about that answer. Wait, that's not a good method for you to use, though, on test day. I saw it on a number of papers, so I feel good about my answer. Number 2. Again, if you've done enough of these, you can look at that and recognize what type of formula that is, and maybe even what R is. But if you're still struggling through them, then write out the first few terms. If K is 1, 2 times 3 is 6. If K is 2, 3 squared would be 9. 9 times 2 is 18. If K is 3, 3 cubed is 27. Times 2 is 54. And yeah, it looks like R is 3. So that means this is a geometric formula. Be careful, because there's 2 geometric formulas. One for a finite number of terms, one for an infinite number of terms. So let's see, that formula is a1, 1 minus r to the n, all over 1 minus r. So a1 we've already got. R we already figured out. N, we're going to the 7th term. And so this is just straight calculator work. Careful with the parentheses and the exponents and negatives and fractions and all that stuff. Again, alpha F1 is a safe place to go if you're not sure about parentheses. And I get 6558. That one wouldn't be too hard to check, because we already wrote 3 terms, so it wouldn't be too bad to write 4 more terms and then, with the calculator add them up and make sure we got 6558. I wouldn't do that with 50 terms. So, if you want to check them, it's up to you. Just recognize that it takes a little bit of time. And I think we said yesterday, save that for the end. If you want to check them by hand, fine, but wait till the end so you don't run out of time punching numbers in your calculator. All right, for part C, again, I'm pretty sure what type of formula or what type of sequence it is, but let's plug things in and see. So 3 to the first is 3, 3 squared is 9, 3 cubed is 27, ... So I'm pretty sure R is 1/3, and the infinite sum formula, a1 over 1 minus r, we're eligible to use that because r is so small, or r is less than 1, that we're okay to use this formula. I'm telling you now, there's, I think, one on the test that you're not eligible. Like, it looks like you should use it, you'll get an answer, but if the numbers are getting bigger, if r is bigger than 1, there is no sum. You can't do it. So 5/3 over 1 minus 1/3. Yeah, so 5/3 divided by 1 minus 1/3 is 2.5. That's an exact answer, so that's okay, meaning it's not rounded. If you have a calculator that turns it into a fraction, or you turn it into a fraction, 5/2 would be okay as well. Oops. Question on any of those? So those are the three sum formulas that you need to, I guess, know how to use, because you can reference them in your notes, but make sure you know when and how to use each one. Arithmetic, geometric, geometric. All right, last little set. This is what we did most recently. Find the fourth term, find the fifth term of those two. So if you're at home, press pause, and we'll go over them when you come back. By the way, for if you're at home or if you're here in class, one of those is a bit of a trick question. So one of those is a regular question, but one of those is a bit of a trick question. So if you're working through one and you think something's not right, you are correct. All right, let's go over these. These are the Pascal's triangle problems. Again, Pascal did a lot of stuff. Fourth term in this, something to the fifth, so I need the fifth row. At the fourth term means 1, 2, 3, 4. So my coefficient will be 10. I get that from the triangle. I'll have 2a to some power. That power will be, let's see, this is the one where we count down. We start at 5 and count down. So 5 of them, 4 of them, 3 of them, 2 of them. So 2a squared. And then I'll have negative x squared to some power. That's the one that counts up, starting from 0. None of them, 1 of them, 2 of them, 3 of them. And at this stage, those two exponents are supposed to add to the overall exponent. Now, that won't be true when we cube the square thing here in a minute, but at this stage, the 2 and the 3 add up to 5. So that's a little bit of a check on what's going on. So 10 times 4a squared times, let's see, if we cube a negative, we get a negative, x to the 6th. So the answer will be negative. 10 times 4 is 40, a squared, x to the 6th. Number 7, find the fifth term of this thing to the third. So we go to the third row, and we look for the fifth term. 1, 2, 3, 4. What the heck? There is no fifth term. No. Just no. There is no fifth term, I guess would be the more technical answer to put. All right, test is open note. I want to do a quick sort of summary of equations. I don't know that you want to write this down. I'll let you decide. But I'm thinking make my own note sheet so I don't have to thumb around everywhere while on test day looking for stuff. So arithmetic has a common difference. Geometric has a common ratio, because we're adding or subtracting with arithmetic. Geometric, we're multiplying or dividing to get from term to term. So the nth term is the first term plus the difference in minus 1 times. For geometric, again, they're going to look different, but if you understand what's going on, they're very similar formulas, because you're going to start at A1, but you're not adding, you're multiplying, and you don't have a common difference, you have a common ratio. but you want to multiply by that ratio n minus 1 times. And then there was a sum formula, n times a1 plus an all over 2. And the geometric sum formula, a1 times 1 minus r to the n over 1 minus r. But then this is where the paths diverge, because the geometric has an infinite sum formula, a1 over 1 minus r. But again, only if terms are getting smaller. If they're not getting smaller, then don't use that formula. I don't know that that's everything that you need to know, but that's a pretty good summary of the equations. That would get you probably most of the way there. And then if you got stuck somewhere, then you could kind of flip back through your notes and find it. And then the last thing we did was Pascal's triangle. You have this in your notes already, so I don't know that you need to write it again. And we just did one of those, so I don't know. I think I would have that as my primary note sheet tomorrow. And then if something was on there that I wasn't sure about, then I could go back and maybe find one that's closer or better notes or whatever. But I feel like that would get you most of the way there. But I'll leave it up for you to decide on how you want to arrange your notes for tomorrow.